Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good. So Rohan, today what do you want to learn?
Sir, today I like to work on like quadratics, like solving problems using quadratic equations.
Okay. Okay. So basically, quadratic equations you mean in standard form, right?
Yes, sir.
Okay, great. So let me share with you a white screen and we'll begin from there. So today our focus will be on problem solving, right? Correct. So when you're trying to solve a problem, you have to analyze it properly and utilize all your learnings, right? So what I will do here is take up an example. So let's say that um, let us say this is a hill, and from a spot in the hill, somewhere, let us say somewhere here, you launch a rocket
Yes, sir.
straight up, vertically upwards, and let us assume that the height from where the rocket is being launched is, let us say, 100 meters from the ground. Is it okay?
Okay, so that's the Y, right, sir?
Yeah, why? And the rocket moves up. Let's assume that the initial we write at v0, initial velocity is, let us say, 60 meters per second.
Okay,
Correct?
sir.
So with time, what will really happen is that this rocket is going to go up, right? Straight, and then turn back and then drop on the floor. Is that okay?
Yes, sir.
That is going to be the path of the rocket. Now, what we need to understand here is that time is not constant. It really goes up and down at a particular spot, right? However,
Yes, sir.
if I put it on a frame, I mean a coordinate plane, let us say. If I put it on a coordinate plane, let's say like this, right? Where I have time t in seconds along the horizontal axis and height h in meters along the y axis. In that case, since the time is moving, right? Time is moving, right? Let's say it took 2 seconds to go up, right?
Yes, sir.
And then let us say it took 3 seconds to come down, whatever. So that means you have already, time is moving. So this portion actually will be reflected kind of like this. Do you see this?
Oh, yes, sir.
Mainly because the time is moving and we are plotting the height at different instances of time. You get the idea?
Yes, sir.
So when you're doing a problem solving, it is very important to visualize. Correct? Now, so we have visualized that it is a vertical motion straight up. However, if I have to plot it on a frame, which is height and time, in that case, it is kind of a stretched parable, which I have shown here on this, right?
Yes, sir.
So visualize and then we represent. So in this case, we choose to represent it on a coordinate plane. And so we have a function which is uh, time and time and height related. Is it okay? Now, once we have represented, we also need to find the equation, right? How do we find the equation to solve? So to find the equation, we may have to use some assumptions, right? So we have assumed that there is, for example, no air velocity. So it is not drifting because of the air. You get the idea.
Yes, sir.
So we are saying uh, no effect because of the air. Air resistance is negligible. Is it okay?
Okay, sir.
So all those things. So we assume ideal condition. You can assume that it went absolutely straight up. You can assume that there is no wind, and therefore it is going to come absolutely down on the same path. Correct? So the velocity which
Yes.
we are considering is upward velocity. There is no horizontal component to the velocity. Is it okay?
Yes, sir.
Now, as you know, distance, we have got one. Height is one distance, right? So if I have to find the final height, I mean, at any instance of time, the height, I can write this as a function h of t, right? So it is definitely equal to the, we already started with some height, let us say h0, right? Initial height, in this case being 100 meters, plus we have a velocity with which it is going up with time. You know, time distance speed formula, right?
Yes, sir.
So if velocity is v0, then v0t will be your height, correct? Because of that velocity with respect to time, correct? Right?
Yes, sir.
Now, remember, everything which goes up has to come down. Can you tell me why it has to come down?
Is it because it's one of the laws?
Yes, because of the gravitational pull. Right? G. So the component which pulls it down at the rate, so G is acceleration. The acceleration with it pulls it up is minus half gt square. So at this stage, we'll not get into the derivation of minus half gt square, but we'll take this as such. Is that okay?
Okay, sir.
So that becomes a general equation, and we can take the value of g as 9.8 meters per second square. Is that okay?
Yes, sir.
So now, from the given conditions, we can write down our equation, right? So for us, the height now becomes equal to what? Initial height is 100 plus velocity is 60 t minus half of 9.8 t square. Do you see? I got a function of time for height. So height as a function of time, I have written, correct? I
Yes, sir.
could rewrite this in standard way. Half of 9 is what? 4.9, right?
Yeah.
So dividing by 2, we get 4. 18 goes 9 times t square with a negative sign. Is it okay? And then we have plus 60t plus 100, correct? Do you see how for this particular application, we have derived a formula based on our assumptions. We are assuming that the rocket is launched vertically upwards with the velocity of 60 meters per second, correct? From
Yes,
the
sir.
height of 100 meters. And there is no air resistance. In that case, with time, the rocket is going to go up and down, right? On a frame, coordinate planes, where the time is moving, it will look like a parabola as shown here, correct? Does it
Yes.
make sense to you? Let's go to a fresh page, and then once we have this problem, we can infer many things, and then we could communicate our results, right? You can say observations or results. Is that okay?
Okay, sir.
And of course, if there is something wrong and if you want to improve on the system, you can provide a feedback. So basically, problem solving means involving all these things together. You get the idea.
Yes, sir.
And if I put it in this kind of a picture, it becomes a presentation of what exactly is going to be there, right? And how are we going to infer something from it. So let's go to a fresh page and now figure it out. So we found that the height could be written as a function of time as minus 4.5 t square. You must have seen minus 4.5 t square in most of the equations
Sir,
regarding
I think it's
parabolic.
4.9.
4.9. Sorry. Oh. 9.8 half, right? 4.90. And velocity we assume to be 60 t, and height we assume it to be 100 meters. So we got one equation. Is that okay now?
Yes,
Now,
sir.
based on this equation, let's try to do some calculations, right? So first part, find initial height of rocket. Tell me. Initial means what? T equals to 0, right?
Yes, sir.
So obviously, if I substitute T 0 here, that means the height initially means 0
It
is
is going to
what?
be 100.
Yeah, all these terms are 0, right?
Yes, sir.
So that confirms our equation. That is from where we launched, right?
Yeah.
Okay. Now, let's figure out how long was it in the air. Or the duration of flight. Let me rewrite this, rephrase as duration of flight. So duration of flight really means that it will go up and then finally it will come down, right?
Yes, sir.
So let's say it goes up and it comes down, correct? So that is what it is. So we know this point where it started, that is 100. And we need to find this point. So we want to find 0, that means, right? So how do you find this? Well, we say 0 equals to minus 4.9 t squared plus 60t plus 100, correct?
Yeah.
Now to find this, we can use quadratic formula. Say t equals to minus b plus minus square root b square minus 4ac over 2a. Do you know this formula?
Yes, sir. The quadratic formula.
Quadratic formula. So substitute the values. So minus b means minus 60 plus minus square root of 60 square, right? Minus 4 times
Minus
a
or
is minus 4.9.
multiplied by 100
Yes.
divided by 200.
2 times a, no, minus 4.9.
Oh, or 2 times even.
Minus 4.9, which is 9.8, correct?
Yes, sir.
Now we have to take positive value because time t, we know, is greater than equal to 0. Is that okay?
Yes, sir.
Since it was launched. Can you calculate this value? Start from the bracket inside. So 60, yeah, calculate 60 squared.
Yeah, I got 3,600 minus, so 490 multiplied by
Add them.
negative. So
Yeah. 4 times 4.9 times 100. And then you square root it.
yes,
And then you take away 60, right?
yes, sir.
And then you divide by 9.8. You actually get two values here. One will be negative, one will be positive. So what values do you get?
Um, for that, sir, I'm still doing the calculations for it.
Okay. Let me write it like this. Minus 60 plus minus 74.57 over minus 9.8. Is it okay? So let's do both
Yes.
minus, then we get a negative answer, right? So we'll
Sir,
add.
I got negative 60 plus square root 5,550 divided by negative 9.8, and then negative 60 subtracted square root 5,560 divided by 9.8.
Answer.
Yeah, no, that was the one I got before. I'm still doing the
Okay, continue.
solving for it.
Continue. Since the denominator is negative, we'll take negative value on the top, right? So both negatives, that should work. So 74.57 minus this, so I get a very big value, 13.73 seconds. What do you get? The positive value.
So 74.57.
So if I divide by 10, so basically 7 plus 6, 13. Yeah, that's okay. 13.7 is good value. 13.7 seconds.
Sir, for the I got the 13.73.
That's correct. I also got the same thing. We'll keep 13.7 as our time in seconds. Is that okay?
Okay, sir.
So basically, the rocket is going to strike after 13.7 seconds. So in this case, we can say actually the domain is what? The domain is that time is greater than equal to 0, but it is less than equal to 13.7. Is it okay? So that
So
will be
greater
the
than
domain.
t.
And we have also come to know that it is going to be around 13.7 seconds in air. Correct?
Okay, sir.
Perfect. So we got this. Now, there are so many other parameters which we can find. So we got 13.7. Let's erase this page and go to a new page. So we got this function h of t, which is minus 4.9 t squared plus 60t plus 100. And we found that time t is between 0 to 13.7 seconds. Clear?
Yes, sir.
Now, how do you find the maximum height? You can do completing the squares.
Yes, sir, I did.
And also, you could say maximum height will be at minus b by 2a. Minus b by 2a. You don't know this?
Yeah, I know this one, sir.
Yeah, because that discriminant part should be 0, right?
Yes,
So
sir.
minus b by 2a you get. So minus b by 2a in this case is minus 60 by 2 times minus 4.9. So find this value of t. How much do you get? 30 by 5, around 5, right?
Yes, sir.
Tell me exact value, and then we'll calculate that value.
I got 6.2. I'm gonna round it up to 6.1. That is what I got.
6 point what? Give me two
Like
decimal places.
negative 6.1.
No, it
Oh,
cannot be
six
negative.
point one two two.
6.12. Okay, no problem. Time is 6.12 for you now, right? Now plug it
Yeah.
inside this, right? So add 6.12 because we can approximate denominator as slightly less than 10, right? 9.8. So you do get slightly more than 6. That is fine. 6.1 is good value. So substitute and find the value of height. How much you get? You should be good at calculations with this, right? Because straight away you are applying all the formulae one after the other. So in this video, we are going to learn how do we apply the formula and get the results using calculator.
So for that one, I have gotten, wait, yeah, I got 183.552 for a.
183.5 meters is your maximum height. You see that? So basically, you calculated just now that this rocket, which was launched from 100 meters, will go up and then down. And total duration of this flight is 13.7. In seconds, right? So this time is in seconds. Height is in meters, right? And we figure out that the maximum height is 183.5 when you launch it from 100 meters. So much of information you got, right? Now, one more calculation which we can do is very interesting, is to see that during what time was the rocket duration for the rocket being above, let us say, 150 meters. Can you calculate this?
Above 150 meters, sir?
Yes. So let's say this is 150 meters. We want these 2 points, correct? Substitute h of t as 150 is solved. Correct? You can bring all the terms together and then you can solve it, right? So bringing them to the left side, for example, will give you 4.9 t squared minus 60 t. And then if you bring 100 minus here, it becomes plus 50 equals to 0, correct? Use quadratic formula to find the value of t here. So t will be 60 plus or minus square root of 60 squared minus 4ac. So 4 times 50 times 4.9 over 9.8. You can calculate this value now, right?
Yes, sir.
Calculate.
So
60
6.
squared minus
So 3,600.
4 times 50 times 4.9. This is 4.9, okay?
Times 4.9, sir?
Yes, sir. Square root this. And then, since this is positive, let's write it down.
51.2, sir.
Okay, that's correct. 51.18. Okay. 60 plus minus 51.18. Okay.
Over 2.
Over 9.8, correct?
Yes, sir. So I'm going to add it by 60.
And then add 2, get 2 values.
Okay, sir.
When you add 60 and then divide by 9.8, you get a higher value, which is 11.34.
Yeah, I got 11.34.
Find the other value. So that means this time 60 minus 51.18, right?
Yes, sir. So 60 minus
8, and then you divide by 9.8. 0.9.
I got 0.9, sir, as well.
So correct. So during this duration, it is above this height. Do you see that?
Yes, sir.
So these are the type of questions which we expect from parabolic path applications. Is that clear to you? So the beauty was that we actually derived the formula, right?
Yes, sir. Could you hear me?
Yes. So in this
sorry, I was lagging a little bit. That's why.
Yeah, that's okay. That's okay. So now, what we really understand that such parabolic paths, you can actually write down an equation, solve, and get all the information which you want to from the equation itself, right? Okay?
Wait, sir. Can you still hear me?
Yes, I can.
Okay. Yeah.
Did you understand all this?
Yeah, now I am. Yeah, before it was just like I was just very laggy, so I got cut out for a few minutes. So
No
is it
problem.
okay if you could repeat what you said, sir?
Okay. So in this question, you see, we have got a lot of information from the project of launching a rocket model, right?
Yes, sir.
So assuming many things, we came up with an equation. Utilizing that equation, we figure out what could be the estimated maximum height of this rocket, what could be the duration of flight for the rocket? What could be the time during which the rocket was above 150 meters in this particular case, right? And we can now complicate the situation. For example, you see how we are going to complicate it? If there is a bird, let us say there is a bird, okay? So we have a bird which goes zoom past, kind of like this, along a path. Is it okay? And
Yes,
if we
sir.
could model the path of the bird, then will the bird hit the rocket? If yes, when? Or when can bird hit the rocket? Is that clear to you?
Okay, sir. So
Right.
we don't know its speed, right, for the bird?
Or we'll have to, let us say a bird hits the rocket after 10 seconds. Is that okay?
Okay, after 10 seconds.
Let us say the bird hits the rocket after 10 seconds. Okay?
Okay, sir.
Right? We know that. We know that, right? We know that the bird hit the rocket, but we also know that it was half the height from where we were standing. You get the idea. That means this was 50 meters. Is that okay now?
Yes, sir.
So let's take this project further. So let me clear this. Okay. So we have this height of the rocket given by the formula minus 4.9 t square plus 60t plus 100. Since we are standing or we are launching the rocket from that height of 100 meters. Okay, so let me say this is my rocket launched. We have figured out that it took total of 13.7 with the maximum height of 183 approximately. This was 100, and now we are saying that the bird which actually flew midway between our position and the earth strikes after 10 seconds. We know this estimate. Okay,
Yes, sir.
find the path of the bird's flight. Now, assumption here is it is a straight path. Is it okay?
Yes, sir.
Okay. Tell me, how will you find this?
So what I would first do is, okay, so looking at the graph, we can tell that the bird's path, we can assume that it is going straight in a straight line, so it's a linear equation.
Yes.
And we already know, like, from the equation, it is said that the bird is half the distance of the rocket, meaning that we started at 100 meters. So the bird must have started at 50.
Correct.
And at around 10 seconds, the bird and the rocket might have had a collision.
Correct.
So from there, we can interpret the distance between the beginning part before its maximum point and after its maximum point, where it is the distance between the two of them,
Yeah. So
to
we can
help
plug
get
in
like a
10.
better understanding.
We can plug in 10 here and find the height at which the bird strikes. Correct. So we have two coordinate points. And if you have two coordinate points, you can find equation of a line. Correct.
Yes,
So,
sir.
so let's put this value of 10 here and calculate.
So
How
for
much do you
that,
get?
sir, I got 210.
You cannot get more than 183, otherwise 183 was wrong. So 100 plus 600 minus 4.9 times 100.
Wait, sir, when I redid my equation, right, sir?
Hmm.
I just read it right now. It seems that I meant to say 283.7 instead of 183.
If it is 283, it's okay because after doesn't matter. So at time t, I want the height at time t.
Oh,
So
at
what was
time
the
t,
height?
what the height would be?
Hmm.
Okay, sir.
Minus 4 times 4.9. Oh, you mean that was wrong? 283, not 183. Okay, okay.
Yeah.
Okay, that's fine. That's fine. So then we know this is 210, right? So if you know this coordinate point is 10, 210, right?
Yes, sir.
You know the slope and y2 minus y1. You can find the slope, right? And you can get the equation, you know the y-intercept.
Yes, sir. Because we already know the 1 point and then we found out the other
Correct.
one.
So 210 minus 50 over time, which is 10 seconds, times t plus the height of 50. That is your equation. Is it okay?
Okay, sir.
16.
Yeah, I got 16, sir.
So that is the equation for the bird. Does it make sense to you?
Yes, sir.
You see, what we have done further is we have actually made it a system of equations. You see, it is a quadratic linear system. Now, when I say system of equation, means more than one equation. So we have a
Okay.
quadratic equation and we have a linear equation. Finding points of intersection between these two is the solution of our system, right?
Yes, sir.
Do you see how we have solved this particular question, right?
Yes, sir. It seems more clear now after understanding it.
Yes. And you also understand many times when I was a student, I used to wonder when the rocket went up, why am I sketching it like a parabol? Right? It has gone up, it should come down, right? But now I realize, well, it is the time which is flowing, which stretches, correct? So we are seeing that height with different time, right? You understand?
Yes, sir.
Actually speaking, the rocket is going up and falling. Perfect. But
Yeah.
we see with the time, every second what is happening, and put that seconds. I mean, you make a table, of course, with time and height, right? So say 0, 100, correct? Likewise, you make your table. But when you plot, you will get a parable. That's what it means, right? Got the
Yes,
idea?
sir.
So that is how we could see our equation. Now, this bird's example, which I have taken, it is not necessary that the bird will strike. Bird might have gone through this path, but then the rocket and the bird could have missed if the bird was faster or slower. You get the idea.
Yes, sir.
So that is possible. But since we are saying after 10 seconds, there was a hit, so we can probably find fairly accurate path of the bird, right?
Yes, sir.
Perfect. So with this, we have learned a lot. Let me summarize it using the use of quadratic formula. What did we learn? We learned that any quadratic equation of the form y equals to ax squared plus bx plus c can be solved, and the solution will be x equals to minus b plus minus square root of b square minus 4ac over 2a, right?
Yeah.
Maximum will be at x equals to minus b by 2a. Is it okay? That is like a vertex, you understand? Maximum
Yeah.
means maximum or minimum, like turning point, right? So at this particular point, that is x value is minus b by 2a. You can plug it in and get the y value. Now, another important parameter here is the square root part, which is b square minus 4ac. This is called discriminant. Now, this could be positive, this could be negative, this could be zero, right? So discriminant could be positive, it could be zero, or it could be negative, correct? So within the square root, if it is positive, then the answer is minus b plus minus something, correct?
Yes, sir.
So that means we get two roots. Roots means solutions.
Yeah, so basically like the x values.
X-intercept. If it is 0, that means the solution is minus b by 2a, right? That is the vertex we're talking about, correct? So one root. Is it okay?
Okay, sir.
But if it is negative, negative of a square root is not real. So it is imaginary, not real.
Okay, man.
We call it imaginary number. Correct? So b square minus 4ac is a very important parameter, which is called discriminant. And by analyzing the discriminant, we can figure out how many solutions do we have. This is called analysis of discriminant, right?
Yes, sir.
So given any equation, you can easily figure out how many solutions will you have. Now let me give you based on this examples. So if I have y equals to, let's say 2x squared plus 3x minus 5, right? Tell me how many solutions?
3x minus 5, sir.
Yes.
So it seems like there'd be, for the first one, like looking at roots, right? There's like x
b
intercepts.
square minus 4ac. You only
B
calculate the
square
value of b square minus 4ac and check. So in this case, b square will be 9 minus 4 times a and c, which is 2 and minus 5. So it is always greater than 0, right? Do you see that? Because
Yes,
both
sir.
are positive.
So it's greater than
In this case, b square minus 4ac. b square is what? b square is 0, right?
0.
Minus 4 times 1 times 5, right? So it is less than.
It's less than 0.
No solution. You get the idea. Let me give
Yes,
you a
sir.
general equation. X square plus 2x plus k, right? Now find the value of k, for which we could have two solutions, one solution, or no solution.
Okay, sir. Using b square minus 4ac, right, sir?
Yes, general form. So we have b square, which is 2 square minus 4ac. A is 1 and k, right? So we have to analyze this, right? So it is equal to 0 when? Figure it out. So 2 square equals to 4k. So that means k equals to 1, right? So if k is 1, in that case, we have one solution. Do you see that?
Yes, sir.
Now, if k is more than 1, then this will be negative, right?
Negative. So imaginary.
No real solution.
And then if lesser, then it will be like a 2 roots, right, sir?
Yes. Does it make sense? So we have an equation which is general. We have to find the value of k so that we could predict the number of solutions for the given equation. You get the idea?
Yes, sir.
So these are the different types of questions which may be asked in this unit of solving quadratic equations using quadratic formula. You get the idea,
Yes, sir.
right? So with this, we could end our class today, right?
Okay, sir.
Right. Oh, do you want to take one or two questions from your book? Let's
Sir,
take.
is it okay if we can take 1 or 2?
Yeah, take. So you share.
Okay, sir. I'm gonna share my screen.
Yeah. So we'll take some word problems because general questions we have already done. So we'll take some word problems. Is it okay?
Okay, sir.
Yeah. Go to the exercise string. You have understood all the points we discussed today, right?
Yes, sir. Should
Continue.
I zoom in, sir?
This launch we have already done, right? Okay. So, yeah, wait. Let's do question number 6.
6. Oh,
Read.
so so the length of one leg of a right angle is 7 meters. I mean 7 centimeters more than half of the other leg. The length of the hypotenuse is 3 centimeters more than double that of the shorter leg. Find the lengths of each of the three sides.
Okay. So basically, this is a quadratic Pythagorean theorem. You can make an equation: a square plus b square is c square, right?
Yes, sir.
So you can write x plus 7 whole square plus x square equals to 2x plus 3 whole square, correct? So it's a quadratic equation. You can find the value of x. Not a big deal, right? You can do this, correct?
Yes, sir.
Next question. Yeah. Let's do question number 12.
12.
Yeah.
Okay.
Leave it. Don't expand. Read the
Okay.
question.
A rectangular construction site is enclosed on three sides using 1,200 meters of fencing. The remaining side is formed by an existing
Existing
wall.
wall.
What dimensions enclose 180,000 meters square of land?
So you can assume width to be x. So those will be width. This will be y, right? So from here, we know the perimeter is 1200 meters, correct? So one
Yes, sir.
equation will be x plus y equals to 1200. So 2x plus y equals to 1200, or y is equals to 1200 minus 2x, correct? Correct?
Yes, sir.
What is the area? Area is length into width, x into y, right?
Yes,
Substitute
sir.
y as 1200 minus 1200 minus 2x. Is it okay?
Okay, sir.
So we have a quadratic equation. What dimensions enclose this much of area? Means equated to 1800, 180,000. 180,000 equals to, open this bracket, 1200x minus 2x squared. Is it okay? You
Okay,
have a
sir.
quadratic equation. Bring all to the left hand side. So we get 2x squared minus 1200x plus 180,000 equals to 0. Use quadratic formula, find the value of x. Is that correct?
Okay.
Do you understand it?
Yeah. Yes, sir.
So that
So
is how,
basically,
yeah,
so basically, in these questions here, right, you have to understand what is happening, like create a chart, and then having to create equations and then moving them around, right, sir?
yes, yes, yes. So once you get the equation, it is easy. Getting the equation could be hard, right? So practice questions, and then I think you'll be better off, correct? Question number 10. Can you please read question number 10?
The sum of the squares of two consecutive integers is 365. Find the integers.
Tell me, how will you write the equation? Sum of squares of two consecutive integers. What do you understand by consecutive integers? If one is
So like
x,
a number and one,
x
x and
plus
an x
1,
plus
right?
1.
And it is saying sum of squares of, that means square of this and square of this, when you add this up, is 365. Is that okay now? You get your
Yeah,
equation.
okay.
So you can expand, simplify. You get x square plus, when you expand this, you get a square plus 2ab, which is 2x plus 1 equals to 365, right? Bring them together.
Yeah.
You get 2x squared plus 2x minus 364, right? Equals to 0. We bring it here. And now you can apply the quadratic formula. You can divide by 2 also. You can factor out 2. So x squared plus x minus half of 364. 364 I want, right? So 182 equals to 0. Is it okay?
Okay, sir.
So that is how you could do it. So 182 is what? 91. 182 square root. Find the answer.
For 182 square roots, sir, I got 13.5.
Yeah. So can we do 13 times 180? 13 times 14 is what? 182,
It's
right?
182.
So you can factor, right? So 2 times x 14, because positive number is bigger, right? Times x minus 13 equals to 0. Is it okay? So the x
Yes, sir.
value is minus 14 or plus 13, correct?
Yeah,
So x equals to minus 14 or plus 13,
plus
correct?
13.
Does it
Yeah.
say integers? Sum of two
Yeah.
consecutive integers. You see that. So we have two sets of answers. So one set says, if I use a minus 14, so this is my x value. I have to add 1. So one answer is minus 14 minus 13. The other answer is 13, 14. Do you see that?
Yes, sir.
So that becomes the answer for question number 10. Do you see how we do it?
Yeah.
Did you realize that I factored out 182 so easily because I wanted the sum to be 1? So that means the square root is like very close, right? The,
Yeah.
so zero point 0.5 means zero point 0.5 here, zero point 0.5 there, I get 1, right? Difference?
Yeah.
So this is the best way. If you have a very small number as b, you could square root the product and figure out or estimate at least which are the two numbers involved as product, correct? And we
Yes, sir.
simply found 13 times 14 gives us the result. Is it okay?
Okay, sir.
So good. We are going to end this here and you can stop sharing, but you need to summarize today's learning. So Rohan, what did you learn today?
Today I learned how to use quadratic formula for solving problems and how I can have like different methods of solving it when analyzing the equation and easily creating a problem from it and working back and forth with it.
Perfect. So you have mastered the skills. That's very good. And these skills will be required not only in grade 10, but in grade 11 and 12 also.